వచ్చిందంటే ఇక చాలు. టఫ్ టు అండర్స్టాండ్. పీపుల్ అసలు థీటాలు తెలియదు. What happened is, how many? What happened? This is all. This is.
I can't see your video. It's showing that it's on, but
It's like a running.
nothing's happening.
Still okay. Should he join? Oh, yeah. All right.
He joined, huh?
Hmm.
Sir.
Yes, yes. Right.
Yes, sir.
Okay. Then I think after that, I'm going to explain the yes, vectors also come into this 2D motion mostly. Then which is easy for you guys. Okay. Yes. When I want to describe the when I want to describe the motion in a 2D, basically, I would definitely need to understand vectors and scalars, especially. So we already know that what is vector and what is scalar. I think we have discussed, right? Vector and scalars. No? So vectors mean it should have a direction and magnitude, right? So scalar, they don't have the direction. Scalar do not have any direction, but it has a magnitude, right? So what is the time if I ask you? Is it a time is a scalar or vector? What is the time now? Scalar, right?
Yes, sir.
What is the distance now? What is the distance from A to B? It's
Scalar.
scalar, right? What is the displacement from A to B? It's a vector quantity. Okay. Velocity is a vector quantity. So I mentioned here distance is a scalar, speed is a scalar, mass is also. How much weight you are, it doesn't change, right? Weight. So energy scalar, density scalar, length, area, volume, all scalar, time is also temperature, work, all these quantities are the scalars. Coming to the vector quantities, which are magnitude and direction. So displacement definitely require direction, velocity require direction, weight also, mass is different, mass is scalar, but weight becomes vector quantity. Acceleration vector, force is vector, impulse, pressure, momentum, gravity, drag. All this terminology, I think you know that, but I can explain later. Drag is a kind of force only. Gravity is also force. Pressure also kind of force by area. Impulsive force into time. Force, acceleration, everything you think no. Yes, drag is kind of like a liquid approach. Air also sometimes. Right. So then there are types of vectors are there. So what are the types of vector? So null vector. What is meaning of null vector? So null means you already understand. Null means zero. What is zero? Zero could be magnitude, right? So zero is also vector. The only thing we can say, this 0 is a magnitude, like a dot. So 0 magnitude. Dot also can be vector. So 0 vector means the vector having the 0, 0 magnitude. Is it clear? Null vector means
Yes, sir.
the vector which are having the magnitude is 0. What is the position vector?
Starting from origin.
Position means, suppose when I draw this, what is my this position? This is a position vector R, but it lies in the xy plane. So I should write it this vector as a xi yj. This is the position vector which started from origin, right? And which contain in both, it contain the plane xi plus yj. Suppose if it contain 3D, you should write it zk. So position vector could be xi only, or yi only, zi only. That is 1D. 2D, when you go for xi plus yj, or xi plus zk, or xi plus yi plus yj, sorry, yj plus zk. It could be, these are ijk are the unit vectors. Symbol of unit vectors are caps. You have to keep the caps.
Yes, sir.
So vector representation, when I say position vector, you have to write down like this. But when I represent xi plus yj, you should write it like a caps for ij. Why I'm not writing x cap? Because x is the magnitude, y is the magnitude. You don't need to write anything on the magnitude. So position vector, you have to write arrow. But ijk are the unit vectors. Free vector, a vector starting from the anywhere but origin. It can starting from anywhere but origin. I mean random, like it doesn't have exactly, it's a free vector. You can write it like anything. No straight line also. Free movement, you can say. So unit vector, I already mentioned that unit vector which having the magnitude is 1. So I is the unit vector because its magnitude is 1. J is a unit vector, its magnitude is 1. K is a unit vector, its magnitude is 1. So whichever vector having the magnitude is 1, we call it as a unit unit vector. Sir, but how do we represent unit vector? People say in the textbook you can see like this: unit vector I is equal to I vector by magnitude of I vector. If this is equal to 1, we call it as a unit vector. The representation of unit vector is E. E is equal to I vector by magnitude of I. Okay, and you're going to get I actually. So, unit vectors or the unit vector which are having the magnitude is 1. 0 vector 0, unit vector 1. That's it. Equal vector, yes, the vector which are having the same magnitude. This is a 2i, 2j. They are not, are they same? Two vector equal direction, equal magnitude. They are only the equal vector. But here 2j is along y direction, 2i is along x direction. They are not. If I write it 2i comma 2i, they are the equal. So if they are 2i, 2j, 2k, 2j, no. 2i is equal to 2i. We call it as a equal vector. What are the opposite vector? 2i minus 2i. They are equal vector, but they are opposite direction. One is x positive x direction, the other negative x direction. If it is positive x direction, you should take plus. Negative or same value, But so I can say magnitude are both are same. These two vectors magnitude are same, two only. Only direction indicates different, opposite direction. When I do the magnitude of 2i, 2 minus 2i also 2 only. So magnitude is same, only direction is opposite direction. That's it. So this is about the types of vectors. So how do we add the vectors? How do we add the vectors? How do we add a vectors? Can we add x component of sorry? Can we add two vectors which are acting in two different directions? Let's say, let me give 2i 2i 2j. Can I add this? How can I add these two vectors? I have I also. There are three vectors I gave it here. 2i, 2j, I. How can I add these three vectors? What is the resultant of these three vectors if I add? So you cannot add I and j directly. So you can add directly only I component vectors. You have to add 2i plus I, 3i plus 2j. You cannot tell this 5j, 5i like that. You cannot even write, 5i plus j. No, you cannot write like this. So you are supposed to add similar like components, I component, j component, k component. You're not supposed to add I component with, you can add it, but you have to keep plus like that. You cannot directly involve like add 2 plus 3, 5. No. Okay, you have to write it 3i plus 2j. This is the I component, x direction component, and this is the y direction component. Okay, but if I have a 2j, 5j, I can add this. Simply, I can tell 7j. So I cannot write 2k plus 3i equal to 5k. No. So you cannot, this is, you have to keep like this only. This is this is the minimum way of adding. Okay. So adding of vector, you have to remember that you can add only I component with I, j component with j, k component. If you want to add I and j, you just need to keep plus. That's it. Similarly, you can see here B vector and A vector. Here there are two vectors actually.
Yes, sir.
A vector is this direction, B vector is this direction. So when you add these two vector, you should take from the A to B, A plus B. When you add these two vector, A plus B, because these two are different directions, right? One is acting this direction, the other one acting this direction. So this is not equal to this, right? They're completely different directions. So you have to add the resultant vector should be hypotenuse, like the diagonal of these two vectors. So whenever you take the one vector like this, the other vector is like this, the resultant should be diagonal. So here I am writing diagonal is like connecting both A plus B. The resultant vector should be A plus B, which connect both. One is one beginning of the vector, the other one should be ending of the vector. Okay, because you should show the direction. The resultant vector direction should be this direction, A to B. You should tell that A plus B moving from A to B. So A is this direction and B is moving from this to this. The resultant should be A plus B. Very important point, guys, here. Pranav,
Yes, sir.
what is
Understood,
the
sir.
difference here? What is the difference here? I'm writing here A minus B. I'm writing here A plus B. Tell me. So here,
Yeah.
this
Yes,
vector
sir.
started from here to here, and the B vector actually what beginned from the end of the A vector. A vector started from O to B, let's say. and B vector started from B to C. The resultant vector from O to C. See, O to B is the A vector, B to C is the B vector. The resultant should be O to C. But now in the other case, you can see A, B both are away from the origin. A is going this direction, B is going this direction. So in this case,
Subtract.
resultant should be subtract. You have to do the subtraction. Okay, if they are in the one direction, let's say A is going this direction, from that we started from that point. Okay, in that case you write the A plus B. If they are moving away from each other, different directions, you have to do the subtraction. Remember this difference you have to remember. Okay, when you are writing it like this, it's A plus B. When you are writing this opposite, both are begin from the same point origin in different direction. You have to do the subtraction. If both vectors are started at different points, you have to do the addition. Similarly, this is a theorem you can see. This is a parallelogram theorem actually. Parallelogram, because A, B are acted from the origin, the resultant should be A plus B, right? Because they are moving from the same point here, same point,
Yes, sir.
but I am writing like this. If I write like this is A plus B. Remember this. If I write from
Yes, sir.
like this, A plus B, but I am writing here opposite means up subtraction. Okay, A minus B. So here I am
Yes,
writing from the same point. Resultant also A vector, B vector, resultant started from the O only. Then you can write like this, A plus B. Okay. So this is
no,
equal to this A parallel side same, right? And this side must be equal to this side. So B same, A same. So this is parallelogram. And we have a equation for parallelogram. There is a formula also. I'm going to tell that. I think today class seems like over. Let's see. What's the time now?
10, sir.
10 o'clock.
Exactly.
Yes, sir.
Let me check it. Yeah. I just want to complete this and then stop it. You should remember this formula. I mean, you don't need derivation of this. I mean, this is also you can get a derivation like 4 marks question for intermediate level, but we don't need that. You just need to remember whenever you want to calculate resultant vector equation or so this is the formula you have to remember. If they give the P equal to 2, Q is equal to 3, and theta is equal to 90 degrees. They give like this. And you have to use this formula to find the resultant vector magnitude. So R is equal to root P square plus Q square plus 2PQ cos theta. What are the PQ? P is the one of the vector. This Q is the other vector. And the resultant vector should be R. So now we need to find R. What is the R? So you have to just substitute here. R is equal to P how much? 2. Root of 4 plus 9 plus 2PQ. 2 into 2 into 3. Cos 90 how much? Cos 90 actually 0. I'm going to teach that later. When this is 0, this entire thing equal to 0. Oh, no, sorry. This product equal to 0. Right? So cos 90 0. So you have only P square plus Q square, which is actually 4 plus 9, 13. R is equal to 13. So this is actually direction. Tan alpha is the direction. Which direction is going? This direction or this direction? So tan alpha is a quantity which tells which direction you are going. Downward direction, upward direction. So here also they give the theta, PQ values. You can substitute it. Okay. Sin 91, cos 90, 0. This entire thing equal 0. So Q is given 3, P is given 2. That's it. Tan alpha is 3 by 2. That's it. Okay. So these kind of problem also they're going to ask in the competitive exams. I think we have
Yes, sir.
completed this. And there is an equation for projectile motion in a vertical manner. Like if you are throwing a object from aeroplane, you're throwing object from aeroplane or you're throwing the object from the building, that also the path should be parabola, right? So when you're drawing, I'm not going to teach now this, but it's important to remember also. How can we prove this is a parabola? Same thing. Here we are throwing the object from the building. So there also you
Yes, sir.
have the horizontal component and vertical component, horizontal component and vertical component,
Yes,
horizontal
sir.
and vertical. So we're gonna
Yes, sir.
do it in next class this, and after that we'll do some problems. Okay, based on this projectile motion, we'll do the problems. Okay,
Yes, sir.
this is
Okay,
the
sir.
kind of easy, but we have to discuss. It's too late. Just prepare, revise next class. Whatever we did, just revise concepts. What is the projectile motion? What is the vectors? What are the types of vectors? Uh, so what is the resultant vector parallelogram law? What is the resultant vector? All those you just clear, revise it and come back, and we'll do some problems next class. Okay. Any doubts today, class? Any interesting questions from you?
Sir, no doubt.
But you should ask, just I think I always, I always like the student who asks the question. So
Yes, sir.
definitely there are so many questions you can create it. Every topic you can think and create the question. Okay. Definitely from the next class, you try to ask at least one question for the class. You think
Yes, sir.
definitely you'll get the questions. Okay. So when you passive means you're not asking question means there are two ways. You may understand 100% or you may not understand anything. Okay. So I want you to understand 100%, but you have to ask questions too. Okay. So at least
Yes,
one
sir.
question per day. You try. I mean, I'm not expecting like tough question. I mean, you can think whatever question, easy question also you can ask. It doesn't matter. Or silly question also you can ask. Whatever question you, the way of asking question lead to be a scientist. Why? Why we need to study? What is the importance of this? What is the significance of this? You can ask this kind of question. Where can we use this, sir? Like this, you should try to think, and I want you to be scientist too, right? Okay,
Yes, sir.
Pranav, good night. Thank you.
Yes, sir.
See you day after tomorrow.